Hey everyone. So, in the last class, we spoke about what latitudes are, what longitudes are, what's the definition of a nautical mile, what's a great circle, what's a rhumb line, and how is it that we came up with this concept of a nautical mile. I also said that we'll be dealing with a few calculations which involve distances along great circle and distances along rhumb lines. Now, before we move on to that, there is something which I want you guys to know as the foundation for calculations of this kind. Now, all of us are extremely used to calculating with decimals, right? But in navigation, like I've said, we use a sexagesimal system. A sexagesimal system is the one which involves degrees, minutes, and seconds, basically radians, right? So, how do we deal with this? How do we perform simple operations such as addition and subtraction on these coordinates or in this system? So before we move on to even that, there is something very basic which I want you guys to know. It's a quick revision. We've known that 1 degree is equal to 60 nautical miles, right? 1 degree is made up of 60 minutes, and 60 minutes is made up of, 1 minute is made up of 60 seconds, right? Now, minute is indicated with 1 apostrophe, and a second is represented with 2 apostrophes, right? And usually we write our coordinates in degrees, minutes, and seconds, right? That's how we write our coordinates. So how do we perform some very simple algebraic operations such as addition and subtraction on these coordinates? So to have a quick look on that, let's quickly see that let's say we have first coordinate as 49 degrees, 39 minutes, and 51 seconds. And we have a second coordinate which is 39 degrees, 41 minutes, 42 seconds. So let's say that we were supposed to perform addition on these coordinates, okay? So let's say addition and subtraction. Okay. Now let's write them down. Let's write 49 degrees, 39 minutes, 51 seconds, and 39 degrees, 41 minutes, 42 seconds. The same here. 49, 39 minutes, 51 seconds, and 39 degrees, 41, 42 seconds, right? So let's quickly first look at the addition side. So we'll be dealing with this addition because I'm explaining you and a lot of you are doing this for the first time. I'll break it down in the most extreme detail as possible, but usually when you're doing this you will be using a calculator, and even if most of you do not happen to have a calculator at the time, you'll do this in a much more quicker sense. So let's add them. Let's perform a simple addition. 51 plus 42 gives us 93 seconds. 39 plus 41 gives us what? 80 minutes. And 39 plus 49 gives us 88 degrees. Now if you observe here, isn't 93 seconds more? Usually we cannot have 93 seconds, right? Because 60 seconds automatically will give out as 1 minute, right? So what do? We can write this 93 as what? As 60 plus 33, right? Similarly, this, it's not possible to have 80 minutes, right? Because 60 minutes themselves make 1 degree, right? So what do? We can write this as 60 minutes plus 20 minutes, right? And the degree is the way it is. So if you notice, doesn't this 60 seconds automatically get carried forward as 1 minute here, right? So if I were to add just one step, in the next step this would make it 88 degrees, 81 minutes, and what? 33 seconds, right? Now, like I said, 81 degrees is not possible. How did I get this 81? I have just carried forward this 60 degrees, which becomes 1 minute, and added it onto the minute section, right? So 81 minutes, sorry, is also not possible. I'll have to write this as 60 minutes plus 21 minutes. What does 60 minutes automatically make? It adds 1 degree, right? So what will I get? I'll get 89 degrees, 21 minutes, 33 seconds. That's the answer I get, right? So if I were to perform subtraction, what do I do? What is 51 minus 42? It is 11, right? What is 39 minus 41? Now, because 39 minus 41 is lesser, right? Sorry, this is 9. Now, 39 is lesser than 41. So how do I deal with this? What I do is I carry, just like simple subtraction, I can write this as 48 minutes, and 39 then automatically becomes what? 60 minutes plus what? Plus 39 minutes, right? Because I separated, I broke a degree, right? So 60 plus 39 makes it what? Okay, so if I were to write this whole calculation again, I would write it as 48 degrees, 60 plus 39 is 99 minutes, 51 seconds, minus 39 degrees, 41 minutes and 42 seconds. So what do I get here? 51 minus 42 will give me 9. 99 minus 41 gives me 58, right? And 48 minus 39 gives me 9 degrees, right? So I get 9 degrees, 58 minutes, 9 seconds. If you use a Casio calculator and you were to calculate this, right, you would get the same answer. So for those of you, I will want you guys to copy this down in your notebooks as an example, right? Fine. So this is how we perform simple expressions of addition and subtraction, right? So you guys have understood it's very basic. We just know that seconds cannot be greater than 60, so can minutes also not be greater than 60. Anytime they are greater than 60, the values have to get carried forward, right? Similarly, if we are borrowing from the hours into minutes or from minutes into seconds, we need to add 60 because that's the conversion factor, right? 60 minutes make 1 degree. So every time I break 1 degree, I'll get 60 minutes, right? Every time I break 1 degree, I'll get 60 minutes. If I were to break this 39 minutes, I will have to add 60 here because each minute is also equal to 60 seconds, right? So very quickly, I want you guys to solve another question. Let's try doing this together, right? So let's say our coordinates are 27 degrees, 36 minutes, 20 seconds, and our second coordinates are 82 degrees, 45 minutes, 15 seconds, right? Let's say these are our coordinates. So if we look at adding them, right? So if we add them, what do we get? 27 degrees, 36 minutes, 20 seconds plus 82 degrees, 45 minutes, 15 seconds. Now 15 plus 25 is equal to 35, right? So I get 35 seconds. 36 plus 45, if you look at it, what is 36 plus 45 going to be equal to? That's equal to 81 minutes, and 27 plus 82 will be equal to 109, right? So I get 109 degrees, 81 minutes and 35 seconds. Now is 81 minutes possible? We know it isn't. So what do? We write this as 60 minutes plus 21 minutes. And now this 60 minutes is equal to 1 degree, right? So I have to add it here. So that makes it 110 degrees, 21 minutes, right? 110 degrees. What does it make it? 21 minutes. And 35 seconds. Isn't it? So let's say we were to have, let's say we were to find the difference between these two coordinates. So what do we get? We get 27 degrees, 36 minutes, 20 seconds minus, 82 degrees, 45 minutes, 15 seconds minus 27 degrees, 36 minutes, 20 seconds, right? So 15 is bigger, okay? So 15 smaller than 20. So what do? I need to borrow something from here, right? So what do I make? I make this as 44 minutes and I get this as what? 60 plus 15, isn't it? That makes it what? 75 seconds, right? So when I solve for that, what do I get? Let's write it in green. I cancel this out. I get 44 minutes, 15 minutes becomes 15 seconds becomes 60 seconds plus another 15 seconds. That gives me 75 seconds. So 75 seconds minus 20 seconds gives me what? 55 seconds. 44 minutes minus 36 minutes. 44 minutes minus 36 minutes gives me what? 8 minutes. And 82 degrees minus 27 degrees gives me 55 degrees. So what's my final answer? 55 degrees, 8 minutes and 55 degrees, right? So I hope you guys have understood how do we calculate, how do we add and subtract these points. So I want you guys to quickly pause the screen right now and try solving these addition and subtraction questions. It will help you strengthen your hand in these operations along with degrees, minutes and seconds. All right. Usually, again, I'm stressing on the fact that you will be using a calculator in your exam. I'm talking about DGC exams. But in case you were not to use this or you were to calculate this on a piece of pen and paper, then you already now know how do you operate with these. All right. So moving forward, there's this term that you'll see when you're using to calculate distances along great circles. Okay, this is known as the change in latitude. So let's not make it complicated. Let's understand it very simply. What are we trying to do? We are trying to find the overall magnitude difference between two latitudes. So let's write it. It is the magnitude difference between two latitudes. Now, this is not something I want you to remember by definition. This is just something I need you to understand. So let's say that this is the equator, right? Let's say this is the equator and let's say that this is the prime meridian, right? Let's say we have a point somewhere along this latitude, okay? And let's say that this particular latitude is let's say 30 degrees north. And then let's say we have another latitude which is here. And let's say that this latitude is 10 degrees north. If I'm asked what is the change in latitudes or what is the difference, right? Difference in latitudes. What they are asking me is essentially this distance, right? They are asking me what is the distance between these two. Now, for a fact, I know that the difference between these two is 20 degrees, right? The difference between these two is 20 degrees. So what you just found out is your change in latitude. Okay. A lot of people get confused when they look at lines in two different hemispheres. So let's quickly look at that. So if let's say we were given 2 points, okay, let's say we were given 2 points in, let's say one is along some latitude here, and let's say this latitude is, let's say 47 degrees north, and let's say we are given some other latitude here, right, some point along this latitude. Let's say this is some 38 degrees south. Now if they ask you what is the difference in latitudes, or what is your Ch Lat, then how do you find out? Now why did I use the word magnitude is that I am not trying to find any coordinates. I'm just trying to find what is the length of this line, right? That is what I'm trying to find out. So what do? I know that from the equator this particular line is 47 degrees up, right? The magnitude of this line which is drawn on the screen right now is 47 degrees. And what is the magnitude of this line? I know it is 38 degrees south, right? It's given as 38 degrees south, so I know the magnitude is 38 degrees. How do I know this? I know this from the definition of latitudes, right? So when asked what is the difference between the two, I will just add them both, right? I'm just trying to calculate the magnitude between them, right? How much is the difference between the two, right? So how much is the difference? It will be the sum of 47, that's 47 from 47 degrees north, and 38 degrees. So the difference between them is 85 degrees, right? The difference between them is 85 degrees. How is that? Let's say it is from 47 degrees north till the equator is 47 units, and from the equator to 38 degrees south is 38 units, right? So this is 47 units and this is 38 units, to give a total of 85 units, right? That is what I do. Now let's say that both the coordinates were in the southern hemisphere, right? So let's say that instead of 38 degrees south, instead of all these points, I had both the coordinates in south. Then what happens? Let me just draw the equator and the prime meridian. The lines are just there for your reference. So let's say that there is some point here which is at 40 degrees south, and they give you another point which is at the latitude of 17 degrees south. They ask you what is the difference in latitudes. What is the difference in latitudes? Okay, so take a moment, think about it, and think about your answer, right? So the answer you should get is equal to 23 degrees. There's a difference of 23 degrees, right? Because I want to measure only the magnitude, how much is the magnitude here, right? I know this one is 17 degrees, and then some x amount further will take me to 40 degrees south. So how much is the distance between the two? It is 40 minus 17 to give me this distance, isn't it? This, what we are finding out right now, is called as the change in latitude. All right. So how is this relevant to us? Okay. So how is this change of lat relevant to us? So now let's talk about great circle distances. The great circle distance between any 2 points on the earth can be calculated using a very general equation which involves spherical geometry. Okay. Now this might sound very complex, but this is something that we've learned and we already possess the knowledge for. So let's look at it. Let's look at it with an example. Okay. Let's say they ask me to find the shortest distance. The question says, find the shortest distance between 30 degrees north and 22 degrees north. Okay, they asked me to find the shortest distance between these two latitudes, right? Now for a fact I know that the shortest distance between the two latitudes is going to be a great circle, right? So what I do is I quickly draw a section diagram of the earth, okay, with my equator and my prime meridian. Now mind it, anytime you're solving these questions, I want you guys also to draw a figure because it makes things much more easier. So now they say that I am at some 30 degree north latitude, right? So So let's exaggerate it and write that this is 30 degrees north, right? So let's write it as 30 degrees north. And let's write another latitude here at 22 degrees north, right? So they are essentially asking me that what is the shortest distance between these 2 points. Now for a fact I know that the shortest distance between these 2 points will lie along a great circle, right? It will lie along a great circle, which is nothing but a meridian. So how do I calculate this? How do I calculate this distance, right, between them? Now, what is the Ch Lat? How much is the difference in the two latitudes? The difference between the two latitudes is of 8 degrees, right? I already know this. And I also for a fact know that along a great circle, each degree is equal to 60 nautical miles, right? I know this from the definition of a nautical mile. So how much would 8 degrees be worth? 8 6 are 42, so that's going to be 420 nautical miles, right? I hope that makes sense. So what did we do here? They asked us to find the shortest distance between a point which lies on these two latitudes. We assume, for our assumption to make it easy, we assume that they both lie along the same longitude, right? So when they lie along the same longitude, the shortest distance between them would be along the meridian, and that is a great circle path. So what is the shortest distance? So what I do is I find the difference in latitudes between them. And whatever the difference of latitudes is, from the definition of a nautical mile, I know that each degree is equal to 60 nautical miles. So 8 degrees will be equal to 420 nautical miles on the Earth's surface. That is the difference between the 2 points. Now let's quickly look at another question. Let's say they give us to find the shortest distance between, okay? The question says, find the shortest distance between, let's say point A, which is 51 degrees 37 minutes north, and some point B, which is 51 degrees 37 minutes north, and let's say this is at 12 degrees west, and the second point is also at 64 degrees north, 48 minutes, and 12 degree west itself. So how do I solve this? Let's draw a sectional diagram of the Earth. I draw the prime meridian, I draw the equator. Now I'm told that these points both lie along the same longitude, the longitude of 12 degree west. So let's draw a 12 degree west longitude. Okay, let's say that this longitude is 12 degree west. Then what am I told? I'm told that one point, okay, so this point A is what? 51 degrees 37 minutes, and there is some point B which is at what? 64 degrees, even higher up. So let's change the diagram a little. Let's say that point A lies somewhere here, which is at 51 degrees 37 minutes north, and we have a point B which lies at 64 degrees 48 minutes north, and they both lie on the same longitude of 12 west. Now the shortest distance between them would be a great circle, and the great circle passing through these 2 points is this meridian which we've drawn of 12 degree west, right? It is the longitude of 12 degree west. So they asked us to find the distance now. So how do I do it? I find the Ch Lat, or the difference in the latitudes, right? So what is the difference between the two latitudes? Let's use the subtraction method we used first. So 64 degrees 48 minutes minus 51 degrees 37 minutes gives me what? Let's take a moment and solve this. this gives me 13 degrees 11 minutes. I hope we all got the same answer, right? So 13 degrees and 11 minutes is what I got. What is this? What do you think this is? This is the Ch Lat. That's what we were finding. So now they asked us, fine, if this is the Ch Lat, then how much is the distance? How do we convert these longitudinal or latitudinal difference? How do we calculate or convert this latitudinal difference into a number or a measurement of distance? I multiply it with 60. So I know each degree is equal to 60 nautical miles along a great circle, and each minute is equal to 1 nautical mile. So 13 degrees will be equal to how much? 13 6 are how much? 78. So that's 780 nautical miles from here. And 11 minutes, that adds to 11 nautical miles more. So 791 nautical miles is the distance between these 2 points, right? Let's look at another example. Now, usually there are 5 models with this. We look at each and every model. Now, let's look at the first one. Let's say we are on the same meridian and same hemisphere. Okay, so same meridian, same hemispheres. So let's say point A is 51 degrees 37 minutes north, 12 degree west, and let's say point B is 6 degrees 48 minutes north and again 12 degree west. So they both are on the same meridian, right? And they both are in the same hemisphere also. So let's draw a sectional diagram for this question. So I have my prime meridian telling me which is east and west. I have my equator telling me where is north and south. I draw my longitude of 12 degree west, and now I say that okay, one point is somewhere here. This is point Bravo, and there is some point Alpha, right? Then they asked me what is the shortest distance between them. The shortest distance between them will be along a great circle, which is this, right? And they asked me what is the length of this. What is the length of this line we've drawn? So what do? I know that I have to subtract to find the length of this, right? Why do I subtract? Let's take a moment and understand that. Now I'm told that this angle, right, till this point, drawn from the center till this point, this angle is equal to 51 degrees and 37 minutes, right? That's the angle drawn. That's the definition of a latitude, right? Then they tell me that there is this second angle which is drawn, and this angle is equal to 6 degrees and 48 minutes. So I have been given this complete angle, and I have also been given this smaller angle. I am asked to find this. So what do? I subtract the smaller angle from the larger angle to get the remaining, which is this, right? To get this. So that's what I do. I do 51 degrees 37 minutes minus 6 degrees 48 minutes. You guys already know how to calculate this. So when we calculate this, we will get 44 degrees 49 minutes. Okay, that is the Ch Lat, right? Or difference in latitudes. Mind it, this is just the magnitude, right? This is just the magnitude. That is how much space is there between the two, right? So 44 degrees 49 minutes, if we have to convert these degrees or a value in latitude to a measurement, what do? Because it's along a great circle, we use what we know, that along a great circle each degree is equal to 60 nautical miles and each minute is equal to 1 nautical mile. So when I do that, I do 44 into 60 plus 49, right? That's what I get, because each minute is equal to 1 nautical mile. So what do I get that as? I get that as 2689, right? I get that as 2689 nautical miles. Okay, pretty simple. Let's look at the next question, or the next model rather. If we have same meridian, but we have different hemispheres. Don't worry, you guys have already seen what we do here. So let's say, let's write our coordinates first. Let's say we have point A and point B. We have point A to be 29 degrees. Okay, we have point A to be 29 degrees 30 minutes south along 30 degrees east, and we have point B along 59 degrees 47 minutes north. Okay, again this is again 30 degrees east longitude. So they are along the same meridian, but they are in different hemispheres. So let's draw a diagram. Okay, so we start with a sectional diagram of the earth. We draw a prime meridian to separate east and west, and we draw our equator to separate north and south. Now we are told that there is some point A. Where is this point A? This point A is somewhere along the 30 degree east latitude longitude, but in the southern direction. So let's say this is point alpha, and then we have point Bravo here, right? That is what's given to us. This point is 29 degrees 30 minutes south, and this point is equal to 59 degrees 47 minutes north. This longitude itself is equal to 30 degree east, right? Now we have to find out what is the length of this red line. So how do we do it? Now remember, what did we say? We are just wanting to find what is the magnitude of this line, what is the length of this line. So how do I do that? I for a fact know by the definition of a latitude that measured from the equator, this point is 59 degrees 47 minutes up, and measured from the equator, this point is 29 degrees 30 minutes south. So the total difference between the two is going to be the sum of this line and this line, isn't it? This plus this, right? So what is the Ch Lat here? The Ch Lat is 59 degrees 47 minutes plus 29 degrees 30 minutes. Just looking at the figure, it's very evident that we need to add them, right? So what do we get? We get 89 degrees 17 minutes, right? That is what we get, right? This is equal to what? This is our Ch Lat. What is that? That means the length of this line is equal to 89 degrees and 17 minutes. That is the absolute magnitude of the length of this line. How do I convert this to distance? Again, because I'm measuring the shortest distance, it has to be a great circle distance. And I know great circle distances by the definition of nautical mile. I know 1 degree is equal to 60 nautical miles and 1 minute is equal to 1 nautical mile. So when I do that, I get 89 into 60 plus 17. That gives me what? It gives me 5357 nautical miles. I hope that makes sense, right? Then in the third model, let's say we have 2 points, okay, which are in the same hemisphere, but they lie on the meridian and anti-meridians. Okay, what I mean is, let's say there is a point A which is at 41 degrees 55 minutes north. Okay, and let's say he's at 010 degrees east, right? Let's say there is a point B which is at 21 degrees 17 minutes north and is now at 170 degree west. Okay, now let's just visualize this as to how 10 degrees east and 170 degree west are anti-meridians. Let's just solve that first. So if we look at the earth from top, okay, let's say this is the north pole, then let's say that this is the anti-meridian or the date line, and this becomes the prime meridian, right? This becomes the prime meridian. Then 10 degree east lies somewhere here, right? This is 10 degrees east longitude. Similarly, 170 degrees west lies somewhere here, right? So they are both a meridian and anti-meridian pair. Fine. Now that we've established this, how do we measure the shortest distance between them? So let's say this is our prime meridian separating east and west, right? And we have a equator. Now let's say that these are our meridians and anti-meridians. Okay, so we have one point which is at, okay, let's say we have one point which is at 41 degrees 55 minutes north, and we have a second point which is at 21 degrees 17 minutes north. Okay, now the question is, how do we find out the shortest distance, or how do we draw a great circle path between these 2 points? Now what you need to realize is that we spoke about that any 2 points which are opposite to each other can have an infinite amount of great circles drawn through them, right? Because they're diametrically opposite. We can have an infinite amount of great circles drawn through them, right? But the shortest path, I cannot draw a great circle like this, right? Because it does not divide Earth into 2 equal halves. It's 2 unequal halves. It becomes a small circle. So the only great circle I can draw through them will have to go over the North Pole till the point, right? This is the path I'll have to take, right? So anytime you have a point, okay, you have 2 points which lie on the meridian and anti-meridian, okay, then the shortest distance between them is going to be from over the North Pole or the South Pole. Okay, it is going to be that way. Fine. So now, again, what do we have to find out? We have to find out what is this length, right? We have to find out what is this length. How do we find that out? Now, for a fact, we know that this whole angle is 90 degrees, right? Because that's how our longitudes, our latitudes go up, right? Our latitudes go from 0 degrees latitude to 90 degrees latitude, with 90 degrees latitude being there at North Pole, right? So I can just measure this angle, right? And then I can add it to this angle, right? To give me this whole total angle now. So what can I do? I have 2 options. One, I can subtract it from 90. I can subtract 41 degrees 51 minutes to get this arc, and I can get this arc. Or conversely, what I can do is, if you really think about it and use just very simple geometry which we've learned in school. Okay, let's say I were to connect these 2 points. What I can do is, I know the value of this angle, right? It's from what latitudes are given to me, and I know the value of this angle. I also know that angles on a straight line, this whole angle is equal to 180, right? So I can just do, let me call this angle A and let me call this angle B. So I can just do 180 degrees minus A plus B, right? I can just do that. In my case, that will be 180 degrees minus 45 degrees 55 minutes, right? Plus 21 degrees 17 minutes, which will be equal to what? 180 degrees minus 1 minus 63 degrees 12 minutes, right? So that will give me a remaining of 116 degrees 48 minutes, right? So what is that 116 degrees 48 minutes? It is this angle, right? This angle is equal to 116 degrees 48 minutes, right? Because this angle was equal to this angle was equal to this, right? Fine. Now what do I do? Like every other time, because it lies on a great circle, I know how do I convert this to distance. What do? I multiply it by 60. So I do 116 into 60, and because 48 minutes, I can just add 1 minute is equal to 1 nautical mile. So 48 minutes is equal to 48 nautical miles. So that comes to a total of what? It comes to a total of 7008 nautical miles, right? Alternatively, what you could also do is you can try to solve it individually, right? It would still give you the same answer. Like let's say there was a circle. Sorry, it became a little spherical, but bear with me. Okay, so let's say this is our point alpha. Okay, this is point alpha, and we have a point beta. Point alpha is what? 45 degrees 55 minutes, right? So that's 45 degrees 55 minutes, and this one is 21 degrees 17 minutes. I could also subtract it from this whole 90 degrees. I could also subtract this angle to get the remaining angle, right? So I could just do 90 degrees minus 45 degrees 55 minutes. That will give me what? 48 degrees 05 minutes. Similarly, I could do 90 degrees minus 21 degrees 17 minutes. This would give me what? 68 degrees 43 minutes. When I add these both to get, right, to get this whole complete angle, of which this portion is 48 degrees 05 minutes and this portion is 68 degrees 43 minutes, I will get what? 116 degrees 48 minutes, which is the same as this. And to convert it to distance, again I just multiply 116 into 60 plus 48. Now you can use whatever approach works for you, right? So talking about this, our initial direction will be we'll have to fly northwards to the North Pole, and thereafter once we cross the North Pole we'll have to fly southwards to reach our point, and this distance over the pole is going to be the shortest distance to reach this point. Okay, fine. Now the next model says, what if we are at a meridian and anti-meridian pair, but this time we are in different hemispheres. In that case, what do we do? So let's say point A now lies at 35 degrees 57 minutes north, okay, and it lies on, let's say, 130 degrees east, okay. So and let's say point B is there, which lies on 22 degrees 10 minutes south, but this one lies on 050 degree west, right? These are anti-meridian pairs. Again, how are the anti-meridian pairs? If you look at it from the top, right, and this is our date line, this is our prime meridian, this is our North Pole, then I say we are at some 130 degree east, let's say, which is somewhere here, okay, exaggerated figure of course, and this is another 50 degrees, okay, but this is west, right, of prime meridian, this is east of prime meridian, so this will be 050 degree west. So when I draw this picture, or I draw a sectional diagram of this, I draw my prime meridian, I draw my equators. I say that I know now I'm at a meridian anti-meridian pair. I say that, okay, I'm at some 35 degree east. Okay, and I'm at some 22 degrees 10 minutes south. So they are asking me, what is this distance? Right? I have to figure out, am I exactly diametrically opposite? Probably not. Diametrically opposite would be 35 degrees 57 minutes south and 35 degrees 57 minutes north. They would be diametrically opposite. In that case, I could have flown either from the South Pole or from the North Pole. But I for a fact know that this current point is slightly above. So flying over the North Pole will be a shorter distance. Right? Then, how do I measure this? Just like we did last time, okay, we could use two approaches. We could separate 90 minus this angle, right? And we know how much will it be. Whatever this is, 90 minus 35 degrees 57 minutes plus 90 plus 22 degrees 10 seconds. That's how I want you to look at it, right? So when you go over the whole thing, okay, you get a total of 166 degrees 13 minutes. Okay, now to convert this into a linear distance, okay, this whole arc, okay, this whole arc is what is 116 degrees 13 minutes. You can add it up and check, right? So to convert it, what do we do? 166 into 60 plus 13. What does that give us? It gives us 9973 nautical miles, right? Fine. Now, what do we do if the 2 points are on the equator, right? Because equator is a great circle, right? In that case, what do we do? Okay, to understand this, we'll have to understand another term which is known as Ch long. So let's talk about Ch long in our next class. I hope you've understood how do we calculate distances along great circles, right? Equator is a specific case. You'll understand why, right? Because an equator is essentially, it's a latitude, right? It isn't a longitude. So if 2 points lie on the same latitude, then how do we measure the distance between them? Equator does qualify as a great circle, but we must not forget that equator is also a latitude. So how do we measure distances on a latitude? To check that out, stay connected and I'll see you in the next video. Please go over these questions. Please solve the addition subtraction questions, and if there are any doubts, please let me know. Thanks.